everyone, welcome back to my YouTube channel. In the last video, we have seen Introduction to Additive Manufacturing Technique. Now here, we will see the steps that are involved in 3D printing or the procedure that needs to be followed to 3D print a particular object. To check out the Introduction to Additive Manufacturing, you can go to my previous video whose link is also given up in the right corner. So the first and foremost step is to generate a CAD file. What is a CAD file? CAD stands for Computer Aided Design. So basically, this is a 3D model of the final object that you want to see physically. This can be made using different softwares. Some are paid and some are open source like SolidWorks, AutoCAD, Fusion 360, etc. So this CAD file gives you a detail of the 3D model. For example, a cube will look like this in your CAD file, or a sphere, or any arbitrary shape, maybe a bottle. So CAD file can be any object. Now this CAD file needs to be converted into STL format. STL stands for stereolithography format, or standard tessellation language, So what is meant by the term tessellation? So tessellation is a single unit that when repeated in 3 dimensions or 2 dimensions give you the complete picture. For example, you have a square piece. This is one unit, and if you go on repeating it in 2D, you will get a surface that might be rectangle or a square depending how unit cells you tessellate along each direction. So while converting to STL format, what these 3D CAD softwares does are they discretize these solid surfaces into set of triangles. So STL file format is basically discretization of surfaces of solid CAD designs into a number of triangles. And the end result of a STL file is always a surface file. It doesn't give information about the bulk but only the surface. So one of the main criteria of converting it into STL file is the maximum number of polygons, closed surfaces, etc. For example, this cube will be discretized in such a manner. Say here one triangle, this is another triangle, so on and so forth, one triangle, This is another triangle, so on and so forth. Then this STL file format will have only the surface information for this cube. Now when you have surface information, this surface information needs to be translated into G codes that are actually machine readable codes to enable the 3D printer to traverse over the specific path. So what these G codes give as output? These G code gives the coordinates where the nozzle or laser or whatever mechanism is being used in 3D printing are traversed to create the 3D object. So this is one very basic example of a sliced part wherein these yellow lines, as you can see, are the paths that need to be traversed by the nozzle. So along these lines only the material will be deposited. Material will be deposited only along these lines. These red ones are the outer layers or the boundary layers. These green ones is the inner layer or in the infill layer, and these yellow ones are the main layers. So this will give you coordinates. Say for example, you need to the nozzle need to traverse from 0, 0, 0 to some say 5, 0, 5, 0 in the x-axis along x. Then from 5, 0, 0 to say 5, 5, 0. So like this, G codes are given. G codes also control whether your fan needs to be on or off, the cooling system needs to be on or off, or the what should be the traverse speed. That all can be controlled using G codes. Traversal speed of the nozzle or laser, cool on or off condition of the cooling fan, etc. Other electronics can also be controlled using G codes very well. Once you have supplied the G code to created the G code, then that can be fed to the 3D printer directly, and then the 3D printing process will begin. Then you will see the process of actually each layer being laid down one after the another and your 3D part being printed. Then very carefully the 3D part needs to be removed from the printer bed. Otherwise it can cause damage to both the part as well as the 3D printer. And then is the post processing. Sometimes there are residual stresses, or sometimes or like there are residual stresses that are there in the component, so they need to be relieved. So for that some heat treatment post processing is required. Another is the surfaces might be rough or the dimensional accuracy might not be that great because of the layer thickness or nozzle diameters. So the components need to be machined or polished. or there are supports for overhang parts. So these need to be removed and machined to obtain the final object. So we follow a 6-step process in 3D printing that can be summarized as CAD generation, STL file conversion, G-code generation, then finally 3D printing, then removal of the part from printer, and then post-processing. Sometimes here some pre-processing is also required. For example, in case of fuse deposition modeling printing, the filaments might absorb moisture. This moisture causes the filament to be brittle. So hence they need to be heat treated above their glass transition temperature or recrystallization temperature so that they are brittle again. So that they are ductile again and ready for 3D printing. Similarly, in powder based processes, this powder needs to be preheated to avoid very sharp thermal gradients. Hence, pre-processing also becomes necessary in certain processes. That was all for today. Thank you.